Section 8.2, the nature of covalent bonding. This is the first of two parts. Here's our objective. Describe how electrons are shared to form covalent bonds. Demonstrate how electron dot structures represent these shared electrons. And then the third one is coordinate covalent bonds, but we won't cover that today. Okay. First of all, we have this octet rule. We talked about how 8 is great. Well, when two atoms are trying to form a covalent bond, or they're sharing electrons, they're going to find a way, once again, to get to 8. Their goal. They're always going to try to do that. Usually, these are going to happen with the ones in group 4A, 5A, 6A, 7A. Those are the group ones that are going to do it. We're talking about the nonmetals. The nonmetals are the ones that are going to be covalently bonded. And what you find out is you've got an atom like carbon, which has 4 valence electrons around it. And it's pretty hard for it to lose or gain, so what they do is they tend to show. That's what we're going to have happen. So, single covalent bond is where two atoms share a pair of electrons. They take 2 electrons and they share it. And the advantage of that is that when they're shared, they both get to count those electrons. So that helps them get to 8. So for instance, let's take our first example of hydrogen. Hydrogen has 1 valence electrons. Now hydrogen is kind of an exception in that it's not trying to get to 8. It's happy with 2 because in the first level there's only a S sublevel it can hold 2. So you have these 2 hydrogen atoms, both with 1 valence electron. So, you know, if we did an ionic bond, you think, well, we could go here. And we have a nice, cute little smiley face. And this atom would be happy, the one on the right, but the one on the left, he's not very happy. He's just a naked proton. They don't like that. Okay, so instead, what happens is, let's erase this. Instead, what happens is these 2 share. And when they share, they both get to count those electrons. That pair of electrons gets to be counted by both. So this hydrogen says, hey, I've got 2. This hydrogen says, hey, I've got 2. Both happy. So we can represent it with those 2 dots in between that represent a pair of shared electrons. Or more commonly, we could represent it with a dash. So you're going to see something like H dash H. That's a pretty common thing that you're going to see. Okay, so structural formula represents the covalent bonds by dashes, and it shows the arrangement of these atoms. It also shows any of the unshared electrons we're going to have in there, those unshared pairs of valence electrons. Okay, so that's what we call them, unshared pairs. So for instance, if we were going to do chlorine has 7 electrons. This chlorine, he's got 7, 5, 6, and then this 7, and so these 2 right here are shared between the 2. Therefore, this guy can say, oh, I've got 8, and this guy can say, oh, no, I've got 8. So they're both happy. Let's do a couple of examples. All right, so let's do fluorine. Fluorine has 7, so it's pretty similar to what we just did. This fluorine over here, he's going to have 7. And so what's going to happen is these 2 are going to be shared between them. So we'll just draw that dash in between. The dash counts as 2 electrons. So there's, let me get my counter here. There's 2 here, 4, 6, 8. 2, 4, 6. Actually, there's one missing there, isn't there? 6, 8. Okay, so those are my 2. All right, so let's do water. So in water, typically when you see things, they tend to be very symmetrical. So the water molecule, the oxygen is kind of in the middle. We got 6 electrons. And remember, it's not going to pair those guys up if it doesn't have to. And then we've got a hydrogen over here. He's got 1. We've got another hydrogen. We'll put him down here. He's got 1. So these 2 are going to share here. These 2 are going to share here, and when we do that, the hydrogen, he gets to count that as 2. He's happy. He gets to count that as 2. That's good for him. Here's 2, here's 4, here's 6, and there's 8 for that one. All right, so let's do ammonia. NH3 is ammonia. And you should kind of get used to that. We use it a lot. So when you see NH3, you should know that that is ammonia. Very similar to what we just did. We've got this hydrogen with 1, this hydrogen with 1, this hydrogen with 1, and they're all going to form single bonds here, shared electrons. So this guy says, I've got 2, I've got 2, I've got 2. Nitrogen says 2, 4, 6, 8, so I'm happy. And let's do the last one. CH4 is methane. So carbon has 4. And so it's got 4 electrons, and it's got 4 hydrogens around it. So there's one there, there's one over here, one over here, one over here, and these guys are shared. There's there, 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 and there. And once again, they can all count them. So the hydrogen, each hydrogen has 1 bond, that makes 2, and the carbon has 4 bonds, and that makes 8. Okay, we've done quite a few examples here. I would like you guys to do these. So stop the video and do these in your notes. Okay, just to see if you did some of this right. Electron dot structure, the first one's pretty easy. Chlorine, 7. 1, 2, 3, 4, 5, 6, 7. Bromine, oh, guess what? 7. 4, 5, 6, 7. And iodine, 7. They all have 7. Okay. Now, number 8A, that's kind of tricky if we're trying to draw that. Once again, things tend to be symmetrical. Also, one thing to understand is that hydrogen always has to be on the outside because it can only form 1 bond. It can't form more than 1. So it's going to be on the outside. So we're going to get something like this. We're going to get some kind of setup like that. And so let's just put in our electrons. Hydrogen has 1. Oxygen has 6. This oxygen has 6, and this hydrogen has 1. So here we go. Bond across there, bond across there, bond across there. And let's just count. Okay, this hydrogen has 2. He's happy. This oxygen, he's got 2, 4, 6, 8, so he's happy. This oxygen's 2, 4, 6, 8. He's happy, and this hydrogen has 2, so he's happy. And our last one, PCl3, you've got phosphorus, which has 5. So we'll go like that. And we've got chlorine. Let's get some of this out of the way here. Apparently that eraser doesn't want to work. Okay. And let's put in our chlorine here, and he's going to have 7. 1, 2, 3, 4, 5, 6, 7. Another chlorine down here. 1, 2, 3, 4, 5, 6, 7. And a chlorine over here. 1, 2, 3, 4, 5, 6, 7. Notice once again how symmetrical it is. You know, you've got P in the middle and 3 Cl's on the outside. So this one's going to share. This is going to share, this is going to share, and once again, okay, 2, 4, 6, 8, so he's happy. This phosphorus, 2, 4, 6, 8, he's happy. 2, 4, 6, 8, 2, 4, 6, 8. So they're all happy. Not everything works when you just make single bonds. So atoms can do double or triple bonds also. So that happens at times. We get double and triple bonds. They share 2 pairs or 3 pairs of electrons. Here are some examples. Oxygen, nitrogen, carbon dioxide. Let's take a look at them. Alright, if we want to do oxygen. Oops, let's go back to the marker. Oxygen. We've got 6 electrons. 1, 2, 3, 4, 5, 6. another oxygen over here. 1, 2, 3, 4, 5, 6. If we share this one, and then we start counting, we've got 2, 4, 6, 7. That was just a single one here. It doesn't look like it. So that doesn't work. 7 on both. So what happens is they have to share these too. Okay? So now if we count, it'd be 2, 4, 6, 8. This guy can count 2, 4, 6, 8. And then let's rewrite this because it's going to needs to look a little bit neater than that. And we would go 2 dots there, 2 there. So there's my 4 unshared electrons around oxygen. Let's take a look at nitrogen. And nitrogen has 5. So we've got 1, 2, 3, 4, 5. And then another nitrogen. 1, 2, 3, 4, 5. So if we do that, that's not enough. You can see that it's not going to be enough there. We've got unshared pairs at the top and the bottom. So we've got to share these guys, and we have to share those guys. Now, there's 2. Get to count each one of these as 2, 4, 6, 8. And here's 2, 4, 6, 8. So they're both happy. And the last one they had was carbon dioxide. And in this one, carbon's going to go in the middle. Once again, things tend to be symmetrical. You've got oxygen on the outside with 6. Oxygen on the outside with 6 more. So if we share, we could share these. That looks good. We could pair these guys up. That looks good. And now this oxygen on this side, he's got 2, 4, 6, 8. So he's good. The left side, we need to do the same thing. So we're going to pair these guys up, and we're going to pair these guys up. And I just kind of drew it so it would work out pretty well. And so they both look pretty good, but when we're done, let's redraw this one so it looks a little bit better. And it would look like this. Get my 4 valence or unshared electrons in around that. So there you have it. And that is the end of part 1 on covalent bonding.